Hello, and welcome back to the Disco Tray Studios Twitch stream. Today, I'm going to be talking about a game called SpaceChem. I think it's going to be a pretty interesting game. Um, it's on Twitch, or not Twitch, it's on Steam. That's where I downloaded it from. Um, it's made by, I think it's made by a developer called Zachtronics, and I'm pretty sure that's the same developer who made the game that Griffith was reviewing for the past few weeks, Shenzhen IO. So it'll be cool to kind of see the differences between that game and this game. Um, so what is SpaceChem exactly? We'll figure it out pretty soon as we start playing. But like some of the like initial things that I've learned about SpaceChem so far is that its focus is to encourage computational thinking within the players and kind of get them to start thinking about like algorithm design and stuff like that. I think like the purpose of this game is that you act as a chemical engineer of some sorts, and you have to uh, solve problems while you're out on a space station or something. You can see it kind of looks like we're on like Mars or something, so that'll be cool. Um, so I think there's like a bunch of different ways you can like implement this into a classroom setting. I believe like this game is a paid game, but I believe that you can get a license for it for educational purposes, so that shouldn't be a problem for any classroom setting. Um, so I think there's like a bunch of different things you can do on here. I think it's like a puzzle game. So I think one thing I've read about is that you can save your solutions to like some of the different puzzles and share them with others in the class. So if like you want some of the students to like share some of their solutions, you can have them explain through them, kind of like have them walk you through what they were thinking. Um, and there's a way that you can create your own levels and share them with anyone pretty much. So for like more advanced usages, you could have students create their own solutions, maybe try to solve solutions that others around the world have created. Um, so the audience for this game, it's rated for anyone 14 or and over. So pretty much anyone in high school or college would be a great game to kind of get any kind of intro level computer science or software computer engineering sort of class kickstarted. Um, so let's go ahead and get started with this game. I don't know how long it's going to take to play through, but we can kind of just see how it goes. So we need our profile name. So I'll just go ahead and name myself Andrew, since that's my name. Um, okay. So there's a bunch of different options here. I think I'm going to go ahead and try to make this green a little bit bigger. Oh no, I might not be able to do that. Never mind. Alright, so welcome to SpaceChem. Can you believe it's been over 8 years since SpaceChem first launched? Today we're releasing a community-driven update featuring, oh I guess that's a message from the developers. Oh wow, this is an old game I guess. Okay, so there's options, credits, quit, switch profile, and challenges. I'm guessing we should just go ahead and start the game. Generate forum signature. SpaceChem, a brief introduction, research, a pancakes and spaceships. So this looks like a planet. I'm guessing it's called Cernamere 2. It says orientation is an external video. Oh, so we're not going to do that. Let's just skip the brief introduction. I kind of gave an introduction to the game already. Okay, here's the training. Reactors are programmed with reactions to transform one set of chemical substances into another. Hopefully we don't have to know much about chemistry to complete this game, because I don't really remember much from the chemistry class that I took in high school. Reactors may move atoms, rotate molecules, and modify bonds. Okay. In research assignments, a reactor is programmed to perform a single reaction. Okay. So that's already like kind of similar to how you kind of design functions when you're programming. You want it to like do this one thing. I wonder if that's what they want it to seem like. I'm guessing. These are Waldos. What? Oh, these little circles. Okay, so these little circles right here, they're called Waldos. They grab, move, rotate, and drop atoms. And atoms bonded together into molecules move together. Waldos move constantly and can be redirected with arrow instructions. Waldos execute arrow and reactor instructions of the matching color when passing over them. Okay. Let's continue. Oh wait. This is an instruction which executes when the matching Waldo passes over it. Okay, this thing right here. And executed when the matching Waldo passes over. The instruction accepts a molecule into the reactor. Place a matching instruction in the highlighted square. Okay. Oh wait, this is instruction. The instruction accepts a molecule into the reactor. So we have to place an instruction here. Oh, I guess it has to be red. It has to be red to follow through the input. This instruction causes the grab and drop. This instruction causes the Waldo to attach to and release atoms. This will pick up the newly accepted molecule. Okay. This instruction redirects the Waldo to move in a new direction. Oh, so is that going to be the line? Okay. Oh. Okay. Each square can contain one arrow and one non-arrow. Input, output. Each square can contain one arrow and one non-arrow. Oh, okay. Interesting, interesting. This instruction causes the Waldo to rotate its head molecule. It is included here for demonstration purposes only and is not required for this solution. Okay. What did that even do? Waldos stop moving when they collide with the side of a reactor. Okay. If an atom collides with another atom or the side of the reactor, the simulation will be stopped. Okay. This instruction will cause the attached molecule to be released. This will drop the molecule into the psi output zone. Okay. This instruction will make molecules in the corresponding output zone leave through the output. Produce all of the required molecules to win. Okay. This outputs it. To start the reactor, click any of the 4 play buttons shown below. Buttons further to the right correspond to faster speeds. The play buttons can be toggled by using the keyboard 1, 2, 3, 4, as can the stop button. Tilde, pressing the spacebar will pause and resume. Okay. Um, uh, oh, so we're making oxygen. Gotta make awesome. Interesting. The performance compared to other engineers is as follows. Lap cycles, this reactors used. Okay, so this is a record solution button you can use if you want to remember what solution you used. So you could have the students do that for certain levels, maybe as homework or something, and just use them to so they can talk about these different solutions with each other, and yeah, it could drive some discussion. So these are our stats, I guess. 188 this. So I guess that's how many elapsed cycles we had. I guess you can get less if you try different things. Reactors used 1. Symbols used 9. Okay. Okay. Oh. This is the story, I guess. People die in space. That was the first sentence in the latest letter from my mother. She had never set foot on a ship, let alone off the colony of Sancfroid. When I told her that I wanted to explore the stars, she cried. We were sitting in the local diner, stacks of pancakes swimming in syrup and butter on our plates, with every face watching my mother's tears roll down her cheeks as I continued eating. I was 10. She attached a news article about a recent incident involving a SpaceChem station in a secluded region of the galaxy. Half of the crew had been ejected through the airlock due to a strange malfunction. The survivors were not available for comment. Needless to say, my career choice was wholly opposed. The stakes are just too high. Look at these reports, she said in the message. I could hear her voice rising with each word. I deleted it and turned off the tablet. Ooh, some family issues going on here. The shuttle was en route to the training facility in Cernamere, 2 billions of kilometers away from Sancfroid. In a few hours, I would be setting foot on another planet for the first time. I gazed out the window and watched the stars shimmer in the distance. You've never been up here before, the pilot called back to me. Nope, first time. Then you've never been through one of these jumps either. Sit tight. My hand gripped the armrest as we hit the jump to Cernamere, 2. I thought I could hear my mother crying, but it was just the pilot laughing. Okay. We continue on. Okay. Let's continue. Okay, research. Slightly different. I'm guessing this is still going to be like the tutorial, this whole thing, this whole Cernamere planet. Let's click that. Okay. Atoms and molecules. Atoms are the building blocks of all matter. Atoms of the same element have the same properties. Oxygen, carbon, and iron are examples of elements. Molecules consist of one or more atoms joined by bonds. A molecule is manipulated by a Waldo as a single unit. Water, methane, and salt are examples of molecules. These molecules are all the same. Oh, so the orientation doesn't matter. Okay. These molecules are all different. Okay, because it just depends on which molecules are connected to each other and the number of each molecules. I guess they don't know what the name of these are, and so there's these are all acetylene. Kind of wish I knew more about chemistry. So let's continue. To solve this puzzle, we will have to use the blue Waldo, which behaves identically to the red Waldo, but executes only blue instructions. Wait. Okay, only blue instructions. To create a blue beta input, drop a red A alpha input instruction and right-click on it. Okay. Nice. That's weird. You can switch to drop blue instructions instead of red instructions by pressing the tab key or clicking the blue active button in the layer controls. In the layer controls. I don't know what that is. Let's press tab. Oh, look at that. So we can. Oh. Okay. Yeah. So you can either press here to switch these colors, or just press the tab button. While the red Waldo defaults to the top and the blue Waldo defaults to the bottom, either Waldo can go anywhere in the reactor and use every input and output. To modify instructions, remember to right-click. Okay. Finish this reaction program by dropping the hydrogen molecule into the omega output zone and flushing it out through the output. Oh. Okay, so here's the periodic table of elements. I wonder if we can choose different elements. I guess not. So right now we're just dealing with hydrogen. So grab and drop, we're going to grab and drop a hydrogen into the atom. And then we want to output it. I think we need to have it kind of looping, right? Let's start it. Oh. Maybe we don't need these right now. Okay, let's stop that. That might not be what we wanted to do. We might need to rotate it. Try that again. Wait, is there something I need to use? Hmm. out. Emits each non-attached molecule in specified output zones to corresponding output. Pauses output while output pipe is full. Weld is currently attached to an atom. Oh, okay. I think we need to maybe do that here. Okay, yes. Look at that. Okay, we did it. So yes, very logical game, kind of like drag and drop sort of thing. Guess we'll try out a few more levels, and then we'll end this playthrough. Let's see. Okay, research, crossover, research. Okay. Okay, so we need this one to output 10 platinums. And this one to output gold. Okay, I wonder if this is just... if we just need to do the same sort of thing. I really don't know. Do grab and drop. And then have this go back around. Oh. Huh. Waldo is currently attached to an atom, causes Waldo to release an atom, otherwise attaches Waldo to an atom underneath. Let's try this. Oh, do we have to grab and drop right there? I think we do. So I can create the atom, like right here. I have to do the grab and drop to grab that atom. Nope. Nope. Right here. Let's see. What is the description of this? Accepts a molecule from a specified input, pauses Waldo while waiting for a molecule to arrive. Ooh. Ah. So we need to direct this. I think we can just... So this needs to output platinum. I think this input it has a platinum input. So we kind of have to direct these Waldos to their opposite sides. We'll do that by doing this, and by doing this. Hope it doesn't cause problems if one overlaps with another. I guess we'll see if that causes problems. Grab and drop. Output. Alright. that grab and drop thing isn't working. Huh. I don't think I actually need that. Grab and drop. If Waldo is currently attached to an atom, causes Waldo to release atom, otherwise attaches Waldo to atom underneath. Huh. I'm in that output zone. And it's each non-attached molecule. Oh. This is the wrong kind of output. So yeah, so the output has to correspond to the field that it's in. So I guess these. So yeah, so you can use these Waldos wherever you want. I guess that's what it's trying to tell me. What it was trying to tell me. You can change the input from a alpha to a beta input, and you have to change it to you have to make it correspond with like the color that the Waldo is. Interesting. A lot of things that you have to figure out about how it works. See if that works. So don't, yeah. Wait a second. Wait a second. Okay. So yeah, this takes a lot of cycles. I don't know what the cycles symbolize. But what I'm gonna have to do um is figure out how to. Okay, I'll go ahead and stop this. So I guess I'll just go ahead and get the data input. Put the grab and drop thing here. Make it go this way. Um, this way. I don't know. I think there might be collisions if I do it this way. Interesting. And then have grab and drop here. And then we need, no. We need an output here. It needs to be that kind of output. And redirect this thing here. And here, so now that makes this a cycle. So I think this could result in some collisions. I guess we'll see. Wait a second. Oh, okay. So this little grid, it shows where the molecule will. It will show where the molecule. This shows where the molecule gets dropped on the grid whenever it passes through the input. So that's why I had to put this here. I thought it was just like a few steps ahead of this, but it's not. So if this one gets dropped here, then I need the grab and drop to be right here. All right. Okay, so that makes sense. Yeah, there's that collision. I wonder if I can. Let's see. Pauses Waldo until another Waldo passes over synchronized instruction. I wish I knew how to use that. Oh, I bet I can use that. So we want to wait until the Waldo is like this Waldo's over here. Oh, look at that. Alright, so that sync instruction, so I put the blue one right here, and the blue one reaches that one first, and then okay. So we passed that one. We had 235 elapsed cycles, one reactor used, and 20 symbols used. It looks like it's possible to use less symbols, but not that many less. It kind of looks like there's a wall to like how many symbols you can actually use. So let's continue. An introduction to bonding. Okay, I'll do. It's 11:34 right now. I'll just do one more. Okay. So we're learning. There's something else. Bonders. Add and remove bonds from atoms. Click and drag bonders to move them. Okay. Click and drag bonders to move them. The sync instruction in action. The blue Waldo will wait at the sync instruction until the red Waldo reaches its sync instruction. So that's what we just used in the past level. So adjacent bonders add or remove bonds from pairs of atoms above them. All bonders in a reactor fire together. All bonders in a reactor fire together. Okay. Interesting. Bonders add or remove bonds from atoms. Click and drag bonders to move them. Let's see how this works. Okay, so these are all the bonders right here. Can I move them? No, I guess we can move them. This instruction specifies where a Waldo starts and can be moved like any other instruction, but cannot be created or deleted. Alright, so it's just showing us how we can move these instructions. Okay, so the input, this will input a silver atom from the alpha input into the alpha input zone. Yes. Molecules are placed in the 4x4 grid as shown in the preview. So yeah, so this is where the silver atom will, I guess, spawn whenever the Waldo passes over the input, alpha input instruction. Let's put that there. Grab/drop instructions can be made to only grab or only drop by right-clicking them and selecting from the menu. Okay, so that's nice. That we can kind of choose what they do. In fact, all instructions can be modified by right-clicking them. So it wants us to... Okay. Instructions can be quickly placed by holding the corresponding keyboard key and clicking on a reactor square. By clicking on so D. Okay, yeah, that's just some keyboard shortcuts. Instructions only affect the Waldo that matches their color. Switch between red and blue instructions by pressing the Tab key. Oh yeah, we already learned this. Yeah, we learned that. Anyway, is that where it wants us to put the input? You can also switch between red and blue with the active layers control. These controls will allow you to lock and hide layers. Yes, it's almost like a second tutorial. Grab. This instruction will pick up the fluorine atom that entered through the beta input with the blue Waldo. Okay. So let's let's make that just a grab. Now that both atoms have been input and attached to Waldos, it is time to bond them together. Bonders can be moved and only create bonds when placed adjacent to other bonders. By placing these bonders adjacent to each other, they can add and remove bonds between the atoms directly over them. Okay. When a Waldo passes over a synchronizing instruction, it will wait there until the other Waldo does the same. Okay, so we can take this sync instruction, put it here. Okay, why would we want to place the blue sync one there? Oh, so it wants us to get to drop the fluorine atom here, and then use the red one to bond. So we want the blue one to reach first so it can drop that atom, and then we could call this bond method. We want this red one. Now that the blue Waldo is finished its work, it must return to pick up another fluorine atom. Okay. Oops. We want to use the blue. For creating a bond between two atoms, they are now part of the same molecule and will be moved by Waldos as a single unit. Oops. How did I delete that? Yeah, so you want to drop this one, do the grab, drop, make that a drop, and then have an output. Okay, so that's pretty interesting how that works. Let's see this in action. Oh yeah, there goes our bonded molecules. I wonder if you can bond the molecules multiple times for like, oh. So yes, you can see these bond buttons kind of reacting whenever they get hit by that bond instruction. Alright, so I think that's enough for today. I guess this game is pretty interesting. I can see how it really encourages the critical thinking and the importance of knowing what each little instruction does. Because in real life, when you're coding and writing programs and learning about algorithms, it is really important to know exactly what each little piece of it does, in order for you to create programs that actually do something. So like knowing each little instruction, like each little variable assignment, learning how for loops are working and stuff like that is really important in the terms of programming. And this definitely encourages that sort of thinking. Like you need to learn what the input and output instructions do and what like the sync instructions do. And it's a lot easier to like get started on this than it would be to get Python set up on all the students' keyboards and have them like start coding on the first day of class. Something like that's just is a lot more difficult, and it's just really confusing for a lot of students. I know, like when I started with computer science, college was like my first experience with any of these kind of programming software and IDEs, and it was just really confusing, like starting out and learning how to use them. So like something like this is just really, really nice to have and be able to kind of learn how to like wire your brain to think programmatically. All right. Um, Thank you for everyone who joined to watch this today. Hopefully, it wasn't too confusing. No, it's a little confusing for me, but I encourage you to go try this game out and possibly use it for one of your classes. All right. Thank you for joining me. I'll see y'all next week. Actually, no, I won't, because next week's Thanksgiving. So I'll see y'all maybe whenever we get back. Thank you.